Basically, our project is sensor-based parking assistant system, and we, the teammates, I, Sumant, along with Chandan, Shrestha, Aishwarya, and Nagaraj, are doing the project under the guidance of Swati ma'am. And coming to the project, this is the main problem. That is saying that, see, in many metropolitan cities and twin cities like Hyderabad, Bangalore, and all over the India, we can observe that parking is the main difficulty to everyone, not only for the beginners but also a few of the expertise drivers are also very uh, congested with these parking areas. So out of that curiosity, we decided to make this project for the fulfillment of their need of any expertise or else any beginners or the old age people. See, coming to the problem statement, parking in crowded cities is difficult due to limited space and poor visibility, often leading to the scratches, dents, and stress for the drivers. Existing advanced parking aids are costly and mostly found in the premium cars, leaving a need for an affordable, user-friendly solution for safe, confident parking. Yeah, as discussed earlier, uh, see, we also have this kind of technologies, but it's mainly maintained in the premium cars. Like, see, if they are getting any closer to any kind of obstacles, there will be an alarm, of course, but not all cars have this facility. So, in order to make this affordable and user friendly with every driver, we thought to make this one. Next is an introduction. Parking has become one of the most frustrating parts for driving today. With more vehicles on the road and very limited parking spaces, drivers often struggle in tight areas, basements, and crowded lots where visibility is poor. Yeah, exactly. See, like many of we people, while driving the two wheelers itself, we feel sometimes we do not have enough space to park our vehicle. So, in most of the cities, many people they easily travel from here and there using their two wheelers or four wheelers. The main problems comes with the parking itself. So this poor visibility of the vehicles in front of their vehicle and behind their vehicle, they may lead to the scratches, dents, and sometimes old age people they suffer a lot, and it may lead to major accidents. And this may also lead more stress to the beginners also. So most of the solutions like auto parking or 360 degrees camera are available in luxury cars itself. Like yeah, this facility is mostly available in the cars which is worth of more than 10 lakh. Like example, we can take the high-end premium cars are like Benz, Audi, BMW, and etc. The people who can afford more than 10 lakhs, like we have cars in such a range like Fortuner, Innova, Grand Vitara, and Fronx, and all those things. So these all have this kind of facilities. Not everything. Like few people buy Celerios, Alto K10, Santos, and all those. They do not include all these things. In order to make that, we have decided this one. Our project aims to change that by creating an affordable system that combines ultrasonic sensor to detect obstacles and computer vision for visual guidance and even optional mobile based control. Yeah, our project may also include optional mobile based control because after looking into this project, after its successful run, we can also develop a mobile based app to control this one in the cars from wherever. Like, see, if we install any ACs in our homes, even the ACs or nowadays some fans are also having remote control. That means even in the mobiles also we can operate the fans. If we are in some Varangal and the fan is still on in our home, in Hyderabad, we can still off it. So why not? Why should not we make such mobile-based control for this even? So this makes parking safer, easier, and less stressful even for beginners and elderly people, as I mentioned. So because only the beginners and elderly are the people who suffer a lot due to this. not everybody. See, expertise also suffer with these problems, but due to their experience, they can easily park the car, but not with the beginners and elderly people. What is the main objective of this project is that we use ultrasonic sensor to detect obstacles. See, for example, a car is 10 meters far away from the car which we are going to park. So we put some sort of distance like 5 meters. See, 10 meters is a safe zone. 5 meters is a little bit danger zone, and when it gets closer to the 2 meters, it's highly impossible to park. So we are going to implement this kind of distance using ultrasonic sensor in the code, and hence this is going to be implemented in the project. Provide a real-time visual guidance via camera and OpenCV. See, this Bluetooth module and camera are some optional things. See, for visual guidance, we are going to install the camera, but Bluetooth module is mainly used for the mobile-based control itself. So, as of now, to complete our project, we are thinking that we install cameras, but not Bluetooth now itself. So offer multimodal feedback like buzzer, voice, and visual alerts. See, while going or while taking the reverse, the camera sometimes it may show green, yellow, and red, because green is the safe zone, yellow is somewhat risky zone, and red is completely danger zone. Buzzer, which gives an alarm when we get very close to another vehicle. Okay, and voice, we may also include voice assistant using these Python libraries to make sure that every driver can hear it clearly, reduce parking accidents and improve driver confidence, deliver it low cost and scalable prototype for smart parking systems. Of course, we are going to deliver it affordable prices, because to make smooth run of the vehicles, smooth parking of the vehicles, and to boost the confidence of the driver, whoever it may be. It may be a beginner, it may be an elderly people, or it may be an expertise person. We analyze that there is of course a lot of difficulty in the tight spaces. See, if a space is very free, we can directly go and park in whatever the place we need. So some people also go and park in some zigzag way, but that's not correct. But what happens if the space is very tight? The question raises to everybody. See, for example, if you are going to do such parallel parking, then how are you going to judge your vehicle? Of course, the people who has some lot of experience can easily park it. But what is the point with the elderly and beginner peoples? So that's what the real problem is. For example, if you are going to park your car in a parallel parking is nothing but there will be a lots of cars and only single slot is left for you. And without making any complexity, or without having any complexity, and without making any zigzag things, you have to directly park. So this project is very helpful in judging their length of the vehicle, and also judging like are they going very nearer to the other car, or they are going in a correct way. And it comes, current solutions are expensive, and our approach is that affordable sensor plus AI based prototype. Expected impact is reduce accidents, save time, and increase safety. It means that if we put all these and drivers are able to drive very smoothly, of course, accidents will be reduced. And however, if accidents are going to reduce, their safety is increased. And this may also save time, like manually while you are parking the car, you have to always look backwards, sidewards, or sometimes even front. So with these technologies, we can save our time. So what are the things we are going to do? Hardware control, we use Arduino Mega, and we can also use Arduino Uno, because we are going to make a prototype for it. Ultrasonic sensor, however, it detects the obstacles. Camera module for the visual impact, And image processing like OpenCV is nothing but they capture the image and they show how it's going to be done. Android app is something which is like it's a kind of optional thing. Android app and Bluetooth module, and GPS is also optional because parking slot is found by this GPS. As of now, we are just looking whether a particular tight space uh, we can park our vehicle or not. We are not finding any parking slots which is very nearer to the car. Next comes the ultimate advantage is this system is the increase in safety. Of course, we reduce the accidents and hence it is directly proportional to increase the safety. The system enables the driver to be warned on the real time about the presence of obstacles and direct him or her visually, thereby highly lowering the chances of small accidents while parking. What do you mean by small accidents is nothing but just having some scratches or dents. Even sometimes when they are taking reverse, they may hit other car, and this tail lamp will be broken. And this tail lamp it depends on the cost model of the car. For some cars it may be 10,000, for some cars it may be 50,000, for premium cars it may be in lakhs. So to avoid all this, we are trying to implement this project. It is especially useful to novice drivers and older citizens who can feel stressed about the parking. See, many beginners they drive the car even in the traffic. They stop the car, they move the car, they know all the steering controls. They may uh, run the car, like they may drive the car without any rollback. Of course, they do everything, but whenever it comes to the parking, they cannot judge that easily. Elder people, without their vision, they are suffered. But if they have a good proper vision, then that's fine. So it is mainly used for beginners and some people who are fond of driving but having a kind of vision defects. The other advantage is that affordability and reach. Compared to the full parking assistant features available on high-end vehicles, our solution will be affordable and expandable. Yeah, if it is affordable, many people to buy this. I think I am clear for this. See, most of the people who are here in a middle class range, they cannot buy Benz, Audi, BMWs. Even they cannot buy Fortuner or Innovas also. So to make this affordable, we are including this even in the low range cars like you know uh, Alto K10, Maruti Celerio, all these kinds. So which are mainly used for a small family, and it implies that it can be used as an add-on device to the already existing cars or included into cheaper vehicles, making smart technology more inclusive. Here the cheaper vehicles is not like the advertise that was given about the Tata. Cheaper vehicles here it means that the vehicles which are worthy to the middle class people, not very highly in budget ones. Next comes the prototype. See, after inclusion of all the hardware components, it may look like this. Not exactly. Our system may look like this. This is the ultrasonic sensor. This one is the ultrasonic sensor. This is the camera module, and this is the Arduino board. Here we have chassis and wheels, and here is the buzzer. We have different kinds. This is LED, and here we have taken this mobile as an optional. It may look like, but it's not exactly that. The following is an illustration of a sensor-based parking assistance system, which demonstrate the integration of hardware systems such as ultrasonic sensor, motor driver, camera, etc. Fine. It is the current idea of the obstacle detection and parking assistance. In the literature review, we have given the introduction earlier. Parking system reduce collisions and driver stress. Traditional aids like mirrors, cameras provide limited depth and visibility. See, to be spoken on this point, we can observe that in the mirror, on the mirrors, it is written as objects in the mirror are closer than they appear. See, in mirrors, we can observe only for certain point of view, and in cameras, it gives the visual representation only until some certain height. So to make this advanced, we are including this one uh, as an add-on benefit to already existing technology. Premium vehicles have advanced solution, but low-cost retrofits are limited. Yeah, exactly. As we discussed, premium vehicles have, but we are offering it lower prices. Existing solutions are low cost, good for distance, but affected by reflections and noise. Ultrasonic sensors, see, while they are going to detect an obstacle, if for example there is an sorry if there is like any kind of noise or any reflections that overlap all these obstacles, ultrasonic sensor cannot detect it. Camera systems detect slots and obstacles, but depending on the lighting, not every time cameras will detect all the objects. Only when the lighting is very good it may detect. In-ground sensors reliable but require infrastructure installation. Infrastructure is installation is that we need high level of installing. And radar or lidar, accurate but costly and complex. These two sensors are very costly. Sensor fusion improves accuracy and reliability. And algorithms, classical and AI, we use AI also. Human machine interaction, beeps, voice alerts, and visual improve driver confidence. These are the key insights from the previous literatures that have been written it. So the mobile integration is one of the optional thing. Research gaps. Most systems are expensive but and not suitable for all the vehicles. Of course, many of the previous literature reviews uh, state that this system is very expensive and it is in the premium cars. So that means it is not suitable for even for the cars which cost less than 5 to 6 lakhs. So we have to maintain even for the lower budget cars. Lighting and weather affects the cameras. That's already known. Lack of explainable feedback. Drivers only get beeps, no guidance. Like you are going very close to the uh, other car. We can also implement this, but we have to install some Python drivers. As of now, we are using the hardware code. If this is to be installed, we can put it as an optional. See, camera is absolutely needed, but the mobile and this voice assistant can be optional. Not every car should have some voice assistant. Some drivers may be irritated with this. Low cost embedded solutions with real time processing are limited. Of course, all the embedded solutions are not that expanded. Our contribution is that combines ultrasonic and camera, Arduino and Raspberry Pi. We have buzzers, voice, etc. Optional GPS, and focus on mainly the point is that we focus on affordability, retrofitability, and user-friendly interface. Conclusion is that I just want to conclude that our project is going to address major urban mobility issue. That means the main parking issue. So by combining all the sensors, computer vision, and some optional mobile connectivity, optional GPS, we can give some kind of effective and safe solution for the drivers. This project has strong potential to enhance safety reduction in the accidents and simplify parking in smart cities. With the point is to be noted is that with affordability. And these are the team members once more under the guidance of Swati ma'am, who is an assistant professor in the Department of Computer Science and Artificial Intelligence School of Engineering. Thank you.